Okay, so today we're going to be talking about greatest common factor, GCF, because this is going to be the first way that we learn to factor polynomials using the GCF. So this is just a refresher on what GCF is and how we find the greatest common factor. So this is just a guide example. So you're given two numbers. So these are the two numbers, 12 and 16, and you list all the factors out. So the ones that are circled are all the factors that they have in common, but the GCF is the biggest factor that they have in common. So between 12 and 16, the GCF is 4. So let's look at these examples down here. So we have 20 and 25 in our first. So let's look at 20. So I like to write the factors in a line like this, so like 1 and 20, so that I'll get them from smallest to largest, but you can write it however you want. And then 2 and 10 are factors. And then we have 4 and 5 as our last factors. So as soon as you know you're done is when the factors start to meet and they repeat. So I know I'm done after 4 because 4 times 5 is 20, and then 5 times 4 is 20. So I know I'm done listing the factors. And again, two factors are what two numbers multiply to that number. So like 1 and 20, 2 and 10, 4 and 5 are all factors. So then pick a different color. If we list the factors of 25, we'd have 1 and 25. 2, it's not a factor. 3 is not a factor. 4 is not a factor. But then we have 5 and 5. So the number's already repeated, so we know we're done. So my greatest common factor then, if I'm going to circle it, my GCF would be 5. So GCF is 5. Because that's the greatest common factor between 20 and 25. You can also check your work by seeing when you divide both numbers by that number by the GCF, they have nothing else in common. So if I were to divide 20 by 5, I'd get 4, and then 25 divided by 5, I'd get 5, and they have nothing in common. So that's another way to check your work. All right, let's do the next one. So we have 24 is our first factor. So for 24, my factors are 1 and 24. There's a lot for 24. 2 and 12. 3 and 8. 4 and 6. And then 5. You don't have 5. And then 6 times 4. So I know I'm done because I repeated. Then I have 28. So for 28, I have 1 and 28. 2 and 14. 3 doesn't go into 28. 4 does. 4 and 7. 5 doesn't go into 28. 6 doesn't go into 28. And then I'm back at 7 and 4. Another way to check to see if it's a factor, you could just divide. So if I wasn't sure if 6 was a factor, I could do 28 divided by 6. I get a decimal, so it's not a factor. But then if I do 28 divided by 7, I get a whole number, so it is a factor. All right, so let's look at our factors here. And it looks like 4 is our GCF. Right, and then again, to check it, I'll just put over here, check. So 24 divided by 4, I'm gonna get 6. And then 28 divided by 4, I'm gonna get 7. 6 and 7 don't have anything in common, so I know, so nothing in common, so 4 is the GCF. Okay, so if I divide it out and let's say I had 8 here, they could have 2 in common, so I know I didn't actually find the greatest common factor because they still have a factor in common. But if you get two numbers, in the end, when you divide by the GCF and they have nothing in common, you can't break it down anymore so that they have a factor in common. That is the GCF. Okay, so let's go to the next one. 40 and 10. So 40, I have 1, okay, let me see that. Yep, 1 and 40. I have 2 and 20. 3 doesn't go in. 4 does. 4 and 10. 5 and 8. And then 6 doesn't go into 40. 7 doesn't go into 40. And then we're back at 8 again. And we have 8 and 5. And then 10. We have 1 and we have 10. Then we have 2 and 5. So that's it. So let's look at our GCF. So they have 1 in common, 2 in common, they have 5 in common. They also have 10 in common. So the GCF here is going to be 10. And then the last one, I have 6. So I have 1 and I have 6, 2 and 3. And then 4 doesn't go into 6, 5 doesn't go into 6, so I'm back at 6. And then I have 42. So I have 1 and 42. I have 2 and 21. I have 3 and 14. I have 6 and 7 are my factors. So if I'm looking at all of these numbers here, looks like my GCF is going to be 6. My greatest common factor, okay? All right, so these are the problems down below that are probably going to be new for us because now we have variables involved in it. And this is going to be a little bit different, but still kind of the same thing, taking out the greatest common factor. So we could start with our numbers first. So we can just start with 39 and listing the factors of 39. So we have 1 and 39, 2 doesn't go into 39, 3 goes into 39, we have 3 and 13. These are the only factors of 39, 1, 3, 13, and 39. And then I have 30. So I have 1 and 30, 2 and 15, 3 and 10. 4 does not go into 30, 5 does go into 30, so I have 5 and I have 6, and then we're back at 6. So just from the numbers, the GCF of 39 and 30 is going to be 3. But now I have these variables. So I have a V and a V here, and I have a U. So we're gonna take out, and the same way we take out like the greatest common factor with the number, we're gonna do that with the variables as well. So each one of these has a V. So we're gonna be able to factor out a V from each one. So my GCF in this example would be 3V because each number has a V involved. We can't take out a U because 39 does not have a U. So my GCF is going to be 3V. Okay, so let's look at number 6. So I have 35 to start. So my factors of 35 are 1 and 35. 2 doesn't go into 35. 3 doesn't go into 35. 4 does not. 5 does. 5 and 7. So these are my factors of 35. 1, 5, 7, and 35. And then for 21, my factors are 1 and 21, 3 and 7. And then those are the only factors I have of 21. So my GCF number-wise is 7. But now I have to look at my variables here. So I'm just going to rewrite them bigger so I have more space up here. So I have an n squared and an m, and an n and an m squared. So if I write this out bigger, this is like n times m. And then I have n times m times m. So in this one, I have 2 n's and an m. And this one, I have 1 n and 2 m's. So from both of these, okay, I could take out an n because they have an n in common. And they have an m in common. So I can take out an n and an m. So that means that my GCF is 7 nm. Because I could take out an n from this one for n squared, and there's an n here, and I could take out an m. Even though this has 2 m's, we can only take out 1 m from each. Okay, so we're taking out the greatest common factor, what they have in common. And that's the same thing up here for variables. So let's look down here, number 7. So we have 30. So my GCF, or my factors of 30 are 1 and 30. I have 2 and 15, 3 and 10, and then I have 5 and 6. Those are my factors of 30. And then my factors of 20 are 1 and 20, 2 and 10. 3 doesn't go into 20, but 4 does, 4 and 5. So if I look at my GCF number-wise, okay, I have a 10 and I have a 10. So I know the number will be 10. But then I have my y's. So if I pull out my y squared here and my y cubed, this is like y times y, and this is like y times y times y. So how many y's do they have in common? Okay, this one has 2 and this one has 3. So we can pull out 2 y's from each. So the GCF is going to be 10y squared for this one. Okay, and then the last one, so if we list out our factors, so I have 36, so 1 and 36, 2 times 18 gives me 36, 3 times 12, 4 times 9, and then of course 6 times 6 is 36, right? And then if I do 24, I have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and those are all the factors of 24, because then 5 doesn't go into 24, and then we're back at 6 times 4. So number-wise, my GCF would be 12 from 36 and 24, but then I have to look at my variables. So let's pull our variables out down here again. So I have x times y cubed, and then I just have a y squared. So this is like x times y times y times y, and this is like y times y. So when I look at the variables, the only thing I'm going to be able to pull out is 2 y's. That's what they have in common. So my GCF is 12y squared. Okay. On the second page, there is extra practice if you would like more practice with this, and I'll post the answer key on Google Classroom with the extra practice, but it is not mandatory to do.